Hello there, good day. On this video lecture, I'm going to discuss network monitoring. Okay, so for the topic outline, so on this video, I'll be covering the introduction about network monitoring, the monitored types of information, network monitoring configurations, network monitoring methods, performance monitoring. This includes performance indicators, performance monitoring functions, fault monitoring, problems of fault monitoring and fault monitoring functions, and the accounting monitoring. So this is part and continuation of the FCAPs that we have discussed on the previous video on the network management overview. So let's start. So network monitoring is basically concerned with observing and analyzing the status and behavior of the end systems. So when you say end systems, this pertains to computers, servers, printers, right? VoIP. These are the components that can be found on the end segment of the network. Okay. So also intermediate systems. So intermediate systems pertains to the devices that is located or situated between the end systems or end devices. So this includes routers, switches, firewalls. Okay, so those are intermediate systems. Layer 2 or layer 3 switches. Okay, and subnetworks, so pertaining to the VLANs that make up the network to be managed. Okay, so what are the issues in network monitoring? Okay, so first is what to monitor. So as systems administrator, so one of our duties and responsibility, of course, is to monitor the network. Okay, but what do we have to monitor in the network? So define what is to be monitored. Okay, so next would be how do we monitor it? How to obtain information from the managed resources. When you say managed resources, this pertains to the managed objects. Okay, and these managed objects are the end systems, intermediate systems, and the subnets. Okay, and what to do with the monitored information. So how the monitored information is used in various management functional levels. So basically, on what to monitor, being a systems administrator. So what do we want to monitor on the network? So basically, we want to monitor the performance of the network, the behavior of the network, right? The activities on the network. Okay, so we are not monitoring the persons or the personnel involved within the organizations, but their activities over the infrastructure. Okay, and how do we monitor it? So basically, we are using a third-party software. Okay, so we have a lot of applications that we can use for monitoring the network, monitoring the bandwidth, monitoring the throughput. So basically, in here, we are using mostly application software or programs. Okay, and what do we do with the monitored information? So after gathering all those information, after the observation and analysis, so what do we do with this information? Okay, so basically this information can be used for future planning. Okay, so maybe at the current situation you are encountering some difficulties or problems regarding your network, and the result of your observation and analysis might help you improve the performance of the network in the future. Okay, so basically what to do with the monitored information is that would help you, the team and the organization, to improve the service provided on the infrastructure. Okay, next, monitored types of information. Okay, so this talks about the static information. So when you say static information, these are the information that could be hardly changes. Okay, so current configuration information. So example, if we're talking about the router, so the number and identification of ports on the router is considered to be static information. Okay, so the number of LAN or the Ethernet interfaces on the router is considered to be a static information. Also, if we're talking about the switches, the number of ports available on a switch is considered to be static information. All right. So next would be dynamic information. So dynamic information changes frequently. Okay. So information related to events in the network. So the change of state of a device, for instance, the router serial 0/0/0 goes down, and then after a second it went up. Okay, so these are dynamic information. The change of state from on to off or from up down, these are considered to be dynamic information. Okay, so the transition or transmission and reception of packets are considered to be dynamic information. Okay, so this would basically depend on the number of packet that traverses over the network. So this is considered to be dynamic or ever-changing information. Okay, so this would depend on the number of packet traverses over the infrastructure. Okay, so the next one would be statistical information. Statistical information was derived from dynamic information. Okay, so example are the average number of packets transmitted per unit time. So the number of packets dropped from the network, the number of packets prohibited and denied by the access lists. Okay, so configured on the router. So these are all statistical information. Okay, so next would be the organization of the management information base. So when you say MIB or the management information base, this is basically the database containing the information pertinent to network management. And organization of the MIB includes, of course, the statistical database, the dynamic database, and the statistical or the static database in here. Okay, so again, when we say statistical, these are information derived from dynamic. Okay, and static database, these are the configurations fixed on the devices. Okay, so this includes these components here. Okay, the configuration database, the sensor database. For the dynamic databases, so you've got the event, the state, okay, like what we have mentioned earlier. And the statistical database are, of course, the statistics or the data derived from dynamic databases. All right. So the MIB is basically the storage of the configured information on the device. Okay, so let's talk about monitoring system components. So the first one would be monitoring application. We have mentioned earlier on how do we monitor or how do we come up with the information, okay, so derived from the infrastructure. Okay, so or what tools are we gonna use to capture the information or the data or the packet that we need during the monitoring. So of course we will be using the monitoring application. So monitoring application includes the functions of monitoring that are visible to the user. Okay, so example, performance, fault, accounting. So these are all functions of monitoring that is or that are visible to the end users. Okay, so basically performance, you'll see it and you feel it. Okay, so by using tools like the speed test, okay, so for the internet connectivity, so we can see and compare, okay, so having a benchmark the performance of the network. All right, so aside from monitoring application, we also have the manager function. So manager function performs the basic monitoring function of retrieving information. Okay, so from the previous discussion on the management overview or the network management overview, we've talked about the manager agent paradigm. All right, so on the manager agent paradigm, so we've talked about the duties and responsibilities or the function of each. Okay, wherein the manager is basically the application residing on the server where the administrator is in. Okay, and the agent is basically the operating systems or the software residing on the managed object that captures information locally and forwarded it on the manager. Okay, so that's manager function. You also have the agent function, okay, so which captures data or gathers records, okay, so from the managed object or MOs. So every managed devices on the infrastructure has an agent. And the agent function is, of course, to fetch data from the local device and forward it to the manager. So the manager function is to perform basic monitoring function of retrieving information. So it receives data from the agent. All right. So also, we kept on mentioning managed object or managed objects. So what are these? So managed objects pertains to a management information that represents resources and their activities. So managed objects or MOs are routers, switches, firewalls, workstations, servers. These are all managed objects. Okay, so the device that we are monitoring and controlling are said to be managed object. All right. Next would be a monitoring agent. So the monitoring agent generates summaries and statistical analysis of this management information. Okay, and we use it for future planning, as what I've said on the introduction. All right. So next would be the functional architecture of network monitoring, the manager agent paradigm or model that we have presented on the network management overview. Now let's have some recap in here. Okay. So the manager agent model is basically the relationship between the manager and the agent. Okay. So the monitoring application is basically a manager function. Okay. And on a managed object, there is an agent and of course an agent function. So the communications between the server having the management application or the manager to the agent. So basically this is through or via the use of the Simple Network Management Protocol or SNMP. So we'll be talking about SNMP in the next and upcoming videos. All right. So for the model of summarization, okay, so again, in here is the server. This is where the systems administrator is seated, okay, monitoring the performance of the network via the application. And we have here the monitoring agent whose primary purpose is to summarize, okay, so the information forwarded by these agents. So there might be two or more devices or a lot of MOs connected to the monitoring agent. Okay, so that's it. Next, how about the network monitoring configuration? Okay, so letter A here, manage resources in a manager system. Okay, so there is a possibility that we are actually monitoring, okay, so a device where the application, where the manager is also installed. For example, you want to monitor the performance of your server. So as systems administrator, you are seated in front of the server and you are using definitely a monitoring application. Okay. Now this monitoring application performs a manager function, which is to receive information from the agent. Okay, so the agent is on the managed object. Now, if it happens that you are monitoring itself or monitoring the server, okay, so where the application and the agent is stored, so that is this model here. Okay, so that would be possible. Okay, so you are monitoring your own device. Okay, so the agent is installed on the server, the manager is also installed on the server. All right. Next, resources in the agent system. So with this type of model, the monitoring application or the manager function, or simply say manager, is stored or installed in a computer, okay, different from where the agent is installed. So for example, this is a server here, and I have here a router, okay, and I manage the router using the subnet or the internet, okay. So that is this resources in the agent system, okay. Or also, it is also possible to monitor, okay, or to control any devices or managed object outside the network, or it could be over the internet. And we have here an agent function, which is to summarize all the information gathered from the MOs. Okay? And the fourth one would be a proxy monitor agent. So again, when you say proxy, this is the software that we use so that this proprietary software can communicate with an open systems and vice versa. All right? Next, network monitoring methods. So how do we monitor the network? So one is via polling. Okay? So when you say polling, this is a request response interaction between the manager and the agent. So polling is basically initiated by the manager going to the agent. Okay? So a manager sends request to an agent which processes the request and responds with information from its MIB. All right? So for example, if I am the systems administrator and I am seated in a computer where I control and configure, for instance, a router. Okay? So I am using PuTTY. PuTTY is basically my manager. Okay? And on the router, this router uses an IOS. So basically the IOS captures data, okay, from its MIB, okay, or from its virtual database, and that data will be forwarded to the PuTTY to present it to the administrator. So that is an example of polling. Okay? For instance, the administrator wishes to display or to know the routing table of the router. So we simply execute the command show IP route on the PuTTY application. Okay? So that is an example of polling wherein the manager send a request to the agent and the agent will respond with the request of the manager. So that's polling. Okay? So all the show commands that we use in Cisco routers or Cisco switches or in firewall are all examples of polling. All right? So a manager may use polling to learn about the configuration it is managing, to obtain periodically an update or an update of conditions, or investigate an area in detail after being altered to a problem. So if the action is initiated by the manager, we call it polling. All right? Okay, so how about if, for instance, the router interface serial 00 goes down and the router sends a notification onto the manager? Okay, so is it polling? Again, with this example, okay, so the agent initiated the action and we call it event reporting. All right. So event reporting, the information flow is initiated from the agent to the manager. When you say polling, it is from the manager to agent. All right. So the counterpart of polling is event reporting. So an agent may generate report periodically to give the manager its current status or whenever a significant event happens. Okay, so like for instance, due to intermittent interfaces, okay, so your serial 0/0/0 goes down. After a second, it went up. Okay, so there is a notification from your screen, okay, so about the status of the interface, and we call it event reporting. Okay, so when you're printing something, okay, for instance, and the printer runs out of paper, so there is a notification in your screen, maybe a sort of a message informing you that the printer is running out of paper. So that is an example of reporting, okay, or event reporting. All right. So this is good for detecting problem as soon as they occur. Okay, so because this is real time. All right. You could even configure your device to have some event reporting via your cell phone or via a mobile app on your gadgets. All right. So that would ease the troubleshooting. Okay. So next would be performance monitoring. Okay, so performance monitoring is measuring the performance of the network, or performance monitoring that's absolutely required in network management. Okay, so the objective is to detect and fix problems that cause performance degradation. So you've got slow in performance. Okay, the performance is worse than the usual. All right, so you've got performance monitoring in there. Okay, and what do we do with it? Well, the performance monitoring can be used to better plan network upgrades. Okay, so basically, if you're going to implement a network, so on its first run or initial run, the network is doing good. Okay, and then after some time, okay, so of course the network ages down. Okay, you've got the number of connections also increases. Okay, so what will happen is basically there would be performance degradation due to aging technology. Okay, or due to an increase in the number of users. Okay, so to better upgrade or to better plan and do some network upgrades, that would help, okay, via performance monitoring. Okay, or we could address the problem via performance monitoring. So what are the problems in selecting and using appropriate indicators or metrics? Okay, so basically the first one would be too many indicators in use. Okay, so it's just like you enabled all the features that you have on the application. Okay, so for instance, when you installed Microsoft Office, okay, so you have or you are given these options, what specific feature, okay, needs to be installed on your Microsoft Office package. So you have the option to choose, let's say, Word, PowerPoint, Excel, okay, but you also have this choose all or select all, and then you install it. Okay, now the thing is, you have a lot of applications installed on your computer, but you are not actually using them all. All right, so that is similar with having too many indicators in use, or by having too many components that we want to monitor, and yet some of it we are not using it. Okay, the meaning of most indicators are not yet clearly understood. Okay, so we simply choose to enable them all, but we don't know where to use it, or what's the significance of it, or what's the importance of it on your organization. Okay, so be careful when you install performance monitoring applications, because some of it might not be needed in the organization. Okay, so take note that whenever we check the features on the applications, so that would cause traffic, and that traffic would cause performance degradation. So you choose only indicators which the organization might need most. All right. Next would be some indicators are supported by some manufacturers only. Okay. So why there is too many indicators in use? Because of the bullet number 3. So if I am using Apple, then I'll be using monitoring applications for Apple. So if I'm using Linux, I'll be using monitoring application for Linux. Okay, so that would lead to many indicators in use. Okay, next would be frequently the indicators are accurately measured but incorrectly interpreted by human or the management application. That's a problem here. Okay, so we've gathered the data accurately and correctly, but when we interpreted it, well, problem arises. All right, so we've got an incorrect interpretation of the results. Okay, next would be the calculation of indicators takes too much time. Why? Performance degradation. Okay, so that is because of traffic. Why there is too much traffic? Because you have too many indicators checked on your monitoring application. Okay, so it's a chain reaction. Okay, So next is how do we measure performance indicators? Okay, so it's either service oriented. Okay, so when you say service oriented, we've talked about availability. So availability pertains to the percentage of time that the network system or component or an application is available for a user. Okay, so we measured service oriented via the availability of the device, the availability of the resources. Okay, next would be the response time. So how long it takes for a response to appear at a user's terminal after the user's action calls for it. Okay, response time. For example, you have encountered an error on your system or on your computer and you seek help from the help desk. How long would it take for the help desk to address your problem? Response time. Okay, or how fast are they to resolve the issues that you have? Response time. Next would be accuracy, the percentage of time that no errors in the transmission and delivery of information. Because if there is an error, there is a tendency to retransmit the data. Okay? So again, service-oriented network performance indicators are measured using availability, response time, and accuracy. So the second is efficiency oriented. Okay, so efficiency oriented, we talked about throughput. Okay, throughput is the rate at which application oriented events, file transfers occur. Okay, so throughput is related to bandwidth. Okay, but if we are after the efficiency, we're not talking about bandwidth, but we measure it instead using throughput. Now, what's the difference between throughput and bandwidth? Bandwidth is basically the frequency. It's the difference between the highest and the lowest frequency. So when we say bandwidth, we're talking about the capacity. Okay, the capacity of the internet. What is your maximum speed? All right. What is your minimum speed? Minimum is 0, maximum is 100, for instance. So that range from 0 to 100 is said to be the bandwidth. All right. When you say throughput, this is the actual transfer of data. So if you have 0 to 100 MB and you're getting 90 MB, then that is the throughput. All right. Next would be utilization. So the percentage of the theoretical capacity of a resource, example, transmission line, switch, CPU that is being used. Okay. So we can monitor this via an application, or if you are using your PC, you can monitor the CPU utilization, the RAM utilization, okay, via the task manager, and that is an efficiency oriented performance indicator. Okay, so we measure the performance either via efficiency oriented or service oriented. So of course that would depend. Okay, next, now from the figure here, okay, so what are the elements of response time? Okay, so how long would it take for a device to respond on your inquiry? Okay, is it real time? No, there's no such thing as real time in the network. The mere fact that your data traverses on the cable, on these interfaces, it causes delay. Okay, so the truth is, for every response that we're getting, okay, so there is an integration of delays on it. All right, so the elements of response time, these are delays. Okay, so if you observe here now from the equation, okay, so as what I'm saying earlier, when your data traverses on the cable, there is delay, and it gets into the hardware, there is delay. Okay, so going back again to the cable, another delay, and so on. Okay, so therefore response time is equals to the inbound terminal delay plus the inbound queuing time, all right, plus the inbound service time, and so on. So basically, there is always delay for every response time, right? So it's just that as systems administrator, how do we minimize delays? Okay. Next, performance monitoring functions. Okay. So this includes performance measurement and performance analysis. Now let's talk about performance measurement. So this is the actual gathering of statistics about network traffic and timing. Okay, so we do it via observation. Okay, and of course with the help of tools, we get it. Okay, so typically performed by agents within network devices, and these agents forward the data to the manager. Okay, so via SNMP, and of course the systems administrator can view and analyze, okay, so that data. Okay, so example includes the amount of data in and out of the node, or the number of connections, traffic per connection. So that's performance measurement. Okay, next would be performance analysis. So analyzing the gathered data and presenting it. So example, you've got the total, the average, the min, max, histogram, something like the statistical information about the gathered data. We call it performance analysis. Okay, and usually we compare it, or we do a benchmark of it on the previous records that we have. Okay, and we are expecting, okay, so we've got the improvement or better service provided to the end users. All right, next is synthetic traffic generation. So what is this? So generating artificial traffic load to test, okay, your network. So for instance, if I'm going to design a network that is good for 100 workstations, and I only have 10 here, so I could use the synthetic traffic generator to test whether the network is capable of having 100 workstations, though I only have 10. Okay, so something like doing a simulation test. Okay, it permits the network to be observed under controlled load. Okay, all right, so next would be a typical performance related questions. Okay, so performance measurements can be used to answer a number of questions. So these questions could help us improve the performance. Okay, so if we are asked or invited, okay, so to ask question on how to improve the performance of the network, well, these questions could help you. Okay, number one, why is the response so slow? So if you are the IT personnel and I am the end users and I ask you this question, how would you answer it? Why is the response so slow? Are you going to give me answers like, because the internet is slow, or maybe we have increased the number of users on the network, that is why the response is so slow? Okay, and you ask the same question. Okay, same questions were asked after a year, and how would you address it? Are you going to give us the same answer? Okay, so this is a very loaded question. So why is the response so slow? Okay, next would be, why is the retransmission rate so high? So this is somehow technical. Okay, retransmission happens because the data, or there is a drop on the transmission of packets. Okay, so if there is a drop in the transmission of packet, the tendency is the devices will retransmit it, especially if you are transmitting a TCP packets. Okay, so that requires an acknowledgement. All right, next, is traffic evenly distributed among network users, or are there source destination pairs with unusually heavy traffic? Okay, so for instance, in an organization, basically we give traffic, or we give bandwidth, okay, to every department depending on their functions in the organization. Okay, so allowing or assigning bandwidth to marketing is different compared to assigning bandwidth to accounting personnel. All right, so you assign bandwidth depending on each function, okay, in the organization. All right, next, what is the percentage for each type of packet transmitted? So there should be a higher percent of a successful transmission than failure. Okay, Next, what is the channel utilization and throughput? So we discussed throughput and defined throughput earlier, and the channel utilization. Okay, so we're talking about the ratio here. Okay, so out of, say, you'll have 30 Mbps. Okay, for instance. Okay, so that's your bandwidth. What are you getting from it? Are you getting 30 also? Or are you getting just 20? Okay, so utilization is it should be higher. Okay, and the throughput should also be higher. It should be close to the bandwidth. All right. Next, what is the effect of traffic load on utilization, throughput, and time delays? Okay, so basically with this, with every traffic on the network, your performance has the tendency to degrade. Okay, so if you want to address really the performance, you have to improve the bandwidth, you have to improve the throughput, the utilization, and that would diminish delays. Okay, next, when does traffic load start to degrade system performance? Okay, so for example, in a school, okay, so if you have a class at 7:30 in the morning, okay, so when you came in there early at 6 o'clock, okay, so basically you're gonna have a good internet access, a better internet access. But as the number of students increases in the campus, so you will experience some degradation in terms of internet access. That is because a number of users, okay, a bulk of users are trying to access the same resource that you are accessing. Okay? So you should be able to know the time when the performance degradation happens on the network. And also, you should be able to identify, okay, the peak. Okay, I mean, during what time would be the a very good or excellent internet access? Every Sunday, all right, or maybe 4:30 to 9, we've got a better internet access. That is because less users are in the campus during that time. Okay, so as systems administrator, you should know, okay, the time when to start the allocation of the resources. Okay, so to anticipate the volume of users in the network to avoid performance degradation. Okay, so we have some sort of reallocation of resources maybe. All right, and the last one would be what is the maximum capacity of the channel under normal operating conditions and how many active users are necessary to reach this maximum. Okay, so again, as network administrator or as systems administrator, you should know that this channel or that this network or that this internet could only allow 100 people to access. Okay, so if you have more than 100, then performance degradation starts or begins. Okay, and as systems administrator, you should have the solution to that. Okay, so again, the possible solution is there might be a need for reallocation of resources. All right. Okay, so next would be fault monitoring. Okay, so to detect faults as quickly as possible after they occur and to identify the cause of the fault so that correctional action may be taken. So as systems administrator, well, it's our duty to maintain, okay, a fault-free network. Okay, so problems on fault monitoring. So this includes fault detection problem. So there is unobservable faults. Example, deadlock. Okay, so device not monitorable. Deadlock is unobservable. I mean, you don't know when it will be coming. Okay, so we all know that deadlock happens only if the resources requested by the application cannot be granted. Okay, so there is also partial or partially observable faults, inefficient to pinpoint what the problem is. Okay, or uncertainty in observation, so not clear what really the problem is. Okay, so that's fault detection problem. You don't know the source of the problem, so how can we solve it? Next would be fault isolation problems. So multiple potential causes, too many related observations, Sometimes this is our problem. We have a lot of information, we have a lot of inputs, and we have a hard time to digest. Okay, so we have too many related observations. That is why. So that takes us slow in solving the problem. Okay, interferences between diagnosis and local recovery procedures, and absence of automated testing tools. So we do it manually. So you've got fault isolation problem. All right. Now considering this diagram here, okay, we only have one link, okay, connecting to the server. Now what will happen if this T1 link fails? Okay, so it's DC or disconnected. Okay, so what it says here is that whenever you create connections to the server, for instance, there might be a sort of redundancy. Okay, so that when the primary link goes down, so there is an alternate or backup link. Okay, so that will capture, okay, so the connections with the server or with the devices. All right, so if the primary link goes up, so there is also a chance that it will go back to the original state. I mean, so the backup will go on the backup state, and the primary will go on the primary duty. All right. Okay, so propagation of failures to a higher layers. So basically, being a systems administrator, you should know where each component of a network device works. Okay, so for instance, router basically works on the layer 3. Okay, switches works on the layer 2. Okay, so if there would be a problem, for instance, okay, so on the connections on the router, so basically that would be propagated onto the application layer. Okay, so if there would be problem with the connections here, that can be visualized on the application layer. So we could have something like, if we can initially ping the connection, then after some time we've got request timeout. All right, or if there would be a problem on the lower layer, so that would be propagating up to the highest layer. All right, so that would aid troubleshooting. Okay, so how would you start troubleshooting in here? So are you going to use a bottom-up approach or a top-down approach? Okay, so usually if there would be a problem on the hardware, that propagates onto the higher layers. So you should know, okay, the techniques, okay, that is being used on troubleshooting, network troubleshooting specifically. Okay, so next would be the fault monitoring functions. So let's start with logs or logging facilities. So record important events and errors. So logs should be accessible by managers via polling. So we have introduced and defined polling, okay, from the previous slides. Okay, so there should be a logging facilities. Okay, event reporting, sending events error to managers, sending alarms to manager to warn possible problems. So we're talking about notifications here. Okay, so notifications that would be initiated by the agent to the manager. You could also use diagnostic function like the connectivity test. So trace route, okay, or trace cert. All right, trace route on the routers and trace cert on the computers. You can also use the response time test, okay, the liveness test or the ping, okay, the protocol integrity test. You ping 127.0.0.1, so that is to test whether your protocol stack is properly working. Okay, you can also use the loopback test, okay, or same with the protocol integrity test, something like 127.0.0.1. It's a loopback. All right. Next, how about accounting? So accounting monitoring, keeping track of the user's usage of network resources. So communication facilities, computer hardware, software and systems and services. Okay, so how do you monitor the utilization, for instance, of an employee? Okay, So we use application. Okay. So as always, for every monitoring activities, so we use application. So we don't want this to perform manually. All right. So usage may be need to be broken down by account, by project, or by individual user for appropriate accounting purposes. Okay? So before we end up, let's wrap up. So let's summarize what we have discussed and learned from this video. So first, we've talked about network monitoring. Okay? And it is the most basic aspect of network management. Okay? Or part of the systems administration or systems administrator's duty and responsibility. Okay? We also talked about the purpose of network monitoring, that is to gather information about the status and behavior of the network elements. Okay? So information to be gathered includes static, okay, dynamic and statistical information. Monitoring methods, we've talked about polling and event reporting. Okay? Polling initiated by the manager and event reporting initiated by the agent. Also, we've talked about the monitoring functions, performance monitoring, fault monitoring, and accounting monitoring. Okay, so if you will observe, okay, so network monitoring is more on the performance, fault, and accounting. Where is security and configuration? We've got FCAPS, right? FCAPS, fault is there, configuration is missing, all right? So accounting is there, you've got performance is there, and security is not in there. Okay, so the configuration and security will be covered on the next video. Okay, so that is network control. All right, so that ends up the video. So thank you for sticking around and thanks for watching. Have a great day.